Hello friends, this video on Oscillations Part 12 is brought to you by examfear.com. No more fear from exam. Please make sure you have watched all the videos till Part 11 before going ahead with Part 12. So let us talk about velocity first. So let us calculate the velocity in simple harmonic motion using the same concept of uniform circular motion. So let us suppose the particle is at any point P at any time t. Now, what would be the velocity of this particle? The velocity at this point would be tangential to this point. That would, at this point, the instantaneous velocity would be nothing but a tangent drawn to this point. We have discussed all these things in the very previous lessons of your we have discussed all these basic things in the very previous lessons of your syllabus. So at this point of time, for the particle which is moving in a circular path, the instantaneous velocity is represented by this tangent, that is v. So what is the angular position of this particle? Angular position is given by this theta, which we discussed in the previous slide, that theta is nothing but omega t plus phi, where omega is the angular velocity. So this theta is the angular position of the particle and omega is the angular velocity of the particle. So now we want to calculate the velocity of the projection of this particle. So the projection of P will be at P dash. So now you imagine that P dash is another particle, right? This particle executes simple harmonic motion, correct? So we want to calculate the value of velocity for this point P dash. That means we want to calculate the value of velocity along this x-axis. This is x-axis. So we want to calculate the value of velocity along this x-axis for the particle P dash. So now let us draw this diagram more clearly. If this angle is theta, then this angle will also be theta because these are alternate angles which are equal. So if this is theta, this is also theta. Now this is a tangent, right? So it is a tangent means this is at 90 degree with the radius. So this angle is 90 degree. So what will be this angle? This angle will be nothing but 90 minus theta. To understand this more clearly, let us draw this diagram again here. I am not drawing the circle anymore. Let us suppose this is theta. This is point P. So this will also be theta. Now the tangent which is drawn from point P is at 90 degrees to the radius vector and this is my radius vector. This is radius, so this is as 90 degrees. So this angle would be nothing but 90 minus theta, right? So now if we want to find, why did we find this angle? Because we want to find out the component of velocity along the x-axis. So if this is velocity v, so the component of velocity along x-axis, however this is the negative x-axis, but the component of the velocity would be v cos 90 minus theta with a negative sign because it is along negative x-axis, right? If this is v, so this would be v cos 90 minus theta. So this we can write it as minus v cos 90 minus, what is theta? Theta is nothing but omega t plus phi. So this can be written as, what is cos 90 minus theta? That is sin theta. So this can be written as minus v sin omega t plus phi. So the velocity, which is again dependent on time, so the velocity of a particle which is executing simple harmonic motion is given by minus v sin omega t plus phi. So this negative sign, what does it indicate? This indicates that the velocity is directed towards negative x-axis. This negative sign shows that velocity is towards negative x-axis. Right? And what is this v of t? This is nothing but the instantaneous velocity of a particle executing simple harmonic motion. Instantaneous velocity of any particle which is undergoing simple harmonic motion. So, what did we see here? We observed that we calculated basically the velocity of a particle executing SHM using a particle which is moving in a uniform circular path. Now, in order to verify that whether this equation which we received here is the same as what we received when we calculate it directly from simple harmonic motion, let us look at the next slide. So, in this slide, what we will do? We will try to calculate the velocity from the displacement of simple harmonic motion. Now, in simple harmonic motion, in SHM, we know that the displacement vector x of t is represented as a cos omega t plus phi. So, what would be the velocity? Velocity is nothing but rate of change of displacement, that is dx by dt. So, that becomes minus a omega sine omega t plus phi, right? Now, this equation is the same as what we received in the previous slide. Just that in the previous slide, we represented this a omega as v. Because v was what? V was the instantaneous velocity of a particle moving in a uniform circular motion. Now, what is v? V is nothing but a omega in uniform circular motion, where a is the radius of the circle and here a is the amplitude of SHM. So, basically, when we relate both of them, the radius of the circle becomes the amplitude of the simple harmonic motion, right? What happens? The radius of circular motion becomes the amplitude of simple harmonic motion, right? So, we see that the value of velocity or instantaneous velocity of SHM we found by both the ways came out to be the same. So, we conclude that the instantaneous velocity of a particle executing SHM is given by v of t is equal to minus omega a sine omega t plus phi. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.